Hello there, and welcome back. What we're going to do in this video is use properties of the unit circle and 30-degree angles to find the exact values of sine of 30 degrees, cosine of 30 degrees, sine of 60 degrees, and cosine of 60 degrees. So you see here drawn in the figure, we have a unit circle. We remember that has center at 0, 0, and radius 1. That's the definition of a unit circle. And we have two angles, one 30 degrees, one technically negative 30 degrees, drawn together that intercept the unit circle at points x, y. And since basically the negative 30-degree angle is a reflection over the x-axis of the 30-degree angle, that intercepts the unit circle at x negative y, meaning that this distance right here is the same as this distance right here. So that's going to be important when we go to finding these exact values. So first thing to think of here is these two sides here are ones because the unit circle has radius 1 and those lines go from the center of the circle to these points x, y. Now, a thing to see is the entire angle here is really 60 degrees, but it gets better. These are really right angles since the 2 points are located vertically from one another. So that means you have a vertical line intersecting a horizontal line, making an angle of 90 degrees. So those are right angles. And that means that this angle right here is 60 degrees, and this angle right here is 60 degrees, which means that that overall triangle there, I'll highlight it in yellow for you, is an equilateral triangle. So remember, in an equilateral triangle, all the angles are equal, which means all the sides are equal. So that means that this vertical side here is 1. The length of the chord, that anytime you draw a line from one point to a circle to another that's not through the center, that's called a chord, the length of that chord is equal to 1. So that means that this triangle in the first quadrant, I'm going to blow it up in a little bit here. That triangle right there has height 1/2. So let me draw that here. So this triangle right here is the first quadrant triangle there. This side is 1/2 since the whole side is 1. This side right here is 1, and I don't know the length of this side, so I'm just going to call that x. But we know at that point we can use the Pythagorean theorem to find the value of x, because we know from Pythagorean theorem that the length of one side squared plus the length of another leg squared is equal to the hypotenuse squared. So all we have to do is solve for x. So we have x squared, plus 1/4 equals 1, which means x squared equals 3/4, just subtracting 1/4 from both sides, which means x is equal to plus or minus, temporarily, the square root of 3/4. Now, we're only using the positive side because x has to be positive or to the right of the origin. And the square root of 3/4 is the square root of 3/2. So that means the x-coordinate of that point, in other words, the cosine of 30 degrees, is the square root of 3/2. And that automatically also means, since we already know that the y-coordinate is 1/2 a unit above the x-axis, that sine of 30 is 1/2. So that means we have cosine of 30 is root 3/2. Sine of 30 is 1/2. So we're halfway there. So now how do we find these trig functions of 60 degrees? Let's look at another picture. So I'm now basically taking that picture and I'm rotating it 90 degrees. So now my two angles make a 30-degree angle each with the y-axis, 30 degrees going one way and the other. And you notice that the actual angle where this point xy lands on the unit circle has an angle of 60 degrees with the positive x-axis. So we can use similar reasoning here. Now, this side here is still 1 because we know that's an equilateral triangle. Okay, so we know that we have right triangles in both of those. And interestingly enough, we don't really have to do much work here because there's our right triangle. We know this is a half, we know this is 1, and we know, well, that's y. We have the same setup as before, so there's really no need to solve the same equation again. The only thing that's different about it is the variable. So we know that y is the square root of 3 over 2, and we already know that x is 1/2. And since x is the cosine of 60, this gives us that the cosine of 60 is 1/2, and the sine of 60 degrees is the square root of 3 over 2. So there are our 4 exact values for 30 degrees and 60 degrees for the sine and cosine functions.